So, some exam questions then on what we've been doing on coordinate geometry. So the line J has a slope of, has a slope of 2 over 5. The line N is perpendicular to J. Write down the side of the angle between the line J and the line N. Right. What are we going to do here? So, first things first. The line J has a slope of 2 over 5. So that positive or negative? Positive. So here is our line J with a slope of 2 over 5. Go on. Now, the line N is perpendicular to J. So, perpendicular to J, is that going to be running in the same, or is it going to be running across? Across. Go on. We're running across. Perpendicular. Right. Do you remember anything about perpendicular slopes? Right. If the slope is perpendicular, all you have to do to get it is flip it and change the sign. So, anyone know what N, what's the slope of N going to be? Minus 5 over 2. Perfect. That is a perpendicular slope. To get a perpendicular slope, all you do is flip it and change the sign. Now, we still haven't answered their question. Write down the size of the angle between the two lines. 90 degrees. Good girl. Why is it 90 degrees? Well, you go on. Here that down. Why is it 90 degrees? Any two lines that run perpendicular to each other always meet at 90 degrees. Is that okay? Can I make it note that? Any two lines that run at 90 degrees to each other, are perpendicular, or any two lines that are perpendicular run at 90 degrees. Right. The line N goes through the line 6 minus 1. Write down the equation of the line N. And remember the formula for the equation of the line. So if I didn't remember, where did I look? On your phone, off you go. That's my formula for the equation of the line. Go back. Y minus y1 is equal to n times x minus x1. That's if we're looking for the equation of the line. So have we enough information to get the equation of the line? We do. We've x1 and y1. But what about the slope? What about n? What's n? Look for n. So it's minus 5 over 2. Off you go. Get me the equation of the line. Right, we'll have a little look at it then. So my label these 2 points, Dermot. What do I label them? X1, Y1. So it's Y minus Y1 equals M times X minus X1. Right, Julianne. That's Y minus minus 1, isn't it? What's M? Minus 5 over 2 times X minus 6, because our perpendicular slope up here was minus 5 over 2. Great, so how are we getting on? So, what do we got to do with our fraction? How do we get rid of our fraction, guys, from last week? Multiply across by 2, 2, and 2, so that they cancel. 2 by y is 2y. What's minus by minus 1? Plus 1, so it's 2 times 1 is equal to minus 5 times x minus 6. Is that okay? Up here, 2y plus 2 equals minus 5 by x is minus 5x. Minus 5 by minus 6 plus 30 is equal to, move everything to one side, minus 5x minus 2y plus 30 minus 2 is equal to minus 5x minus 2y plus 28. Is that okay? Right, the next bit of that question. The equation of 2 other lines K and L are given in the table below. Complete the table by filling in the slope of each line and a point where each line crosses the y-axis. There is space for more work on the next page. Right. Anyone know what formula I'm going to use here when I have the equation in the line and I'm looking to do something to it? Anyone know where I can go look for it? And before. Off you go. What we have here is we all have these. So, anyone know what am I going to use? Exactly, we're going to use, when we have the equation in the line, and we're looking to use the formula y is equal to mx plus c. Right. What 3 things do you know about this? What's the story with y here? What must y be? Last week, you had practiced this for homework. Anyone who did their homework? Has to be singular. Has to be on its own. Must be singular. What does M tell me, Julianne? Slope. Grace, what does C tell me? Good stuff. Where it cuts the y-axis. Alright, where it cuts the y-axis. Right. So, looking at the line K, Julianne, what is the slope? Off you go and actually do line K and line L for me on your own. So, give me the slope and where it cuts the y-axis. For both of these lines, K and L. Give me the slope of the line and where it cuts the y-axis. You're looking for where this line, what the slope of this line is and where it cuts the y-axis. and you're looking for the slope of this line and where it cuts the y-axis. Using the line again. Y equals x. Right, let's have a look at it. What is the slope of the first one? 1. The slope of the first one is 1. Where does it cut the y-axis? -1. Exactly. So, slope of the first one is 1. Where it cuts the y-axis -1. What is the problem with this one down here, Grace? I can't hear. I can't hear what. There's numbers in front of the y, so what are we going to do first of all? We got to bring the 2x over. So that's minus 3y is equal to minus 2x plus 6. All right, we got to bring the 2x over. Now, we want y in its own, Julianne, so what do? We divide by -3. Y is equal to 2 over 3x minus 2. So what is the slope? 2 over 3, and where does it cut the y-axis? -2. -2. Right. Using algebra, find the point of intersection of two lines. How am I going to find the point of intersection of these two lines? Something we did in algebra. Anyone remember what we did? What you say, Grace? No, I think you're on the right line. I think I heard you whisper it, right? What did you say? Good girl. Simultaneous equation. Whenever you see x's and y's of two lines and you want to find where they intersect, you do a simultaneous equation. Brilliant. Right. First things first, though, we got to make them look like each other. So what's wrong with the top line? So what are we going to do? Move the x over. So we're going to change the top line so it's minus x plus y is equal to -1, and 2x minus 3y is equal to 6. Now, does anyone know what two things I need to work with a simultaneous equation? What about the y's? They need to have the same value, front number, but different signs. So I need to have the same value, but have different signs, so they'll cancel. What do I need to do? They put them with the same value, but different signs. Multiply my top line by 3. Off we go. Get me point of intersection. Yeah, because if I multiply it by 3, that'll be plus 3y and then minus 3y. Off you go. No, I want to cancel my y's. I want to cancel my y's. What do I want to get my value for x? Algebra, I'm sure we're studying for maths in 2 weeks' time. So it work. Top line. Right, guys, what do we get? Right, so we have minus 3x plus 3y is equal to minus 3. 2x minus 3y is equal to 6. These are going to cancel. Minus 3x plus 2x is minus x is equal to minus 3 plus 6, which is 3. Divide by minus 1. X is equal to minus 3. Sub it back into our top line, which is minus x plus y is equal to minus 3. Minus 3 plus y equals, sorry, should be minus 1. Minus 3 is plus 3, plus y is equal to minus 1. Y is equal to minus 1 minus 3. Y is equal to minus 3 minus 4. That okay, guys? Right, 2018, paper 2, not that one. Right, off we go. Have a go at the beginning of this. The coordinate diagram below shows the triangle ABC. Write down the coordinates of the points. So, write down the coordinates of A, B, and C. And then you want us to show that A, B, and C is a right-angled triangle without measuring. And then know how we're going to show it's a right-angled triangle without measuring. Right, first things first, we're going to show you our points right. Jeremy, what you get for A? Good stuff. Julianne, what you get for B? And 2. And Grace, what you get for C? 4, 5. Right. Jeremy, do you know anything about a right-angled triangle? Do you know anything at all about a right-angled triangle? Sorry? All the angles out to 180 degrees. Right, there's one thing. All the angles out to 180. Julianne, know about a right-angled triangle? No. That's nice answers. Grace, know about a right-angled triangle? None of you know the name. Well, if I ask someone in primary school now how many degrees the triangle is, then 180 degrees. What's the main thing we should know about a right-angled triangle? Thank you. One of the angles is? One of the angles is 90 degrees. Right. So, if you're looking at this, which angle is 90 degrees? And say C, how do you get an angle? You must have 3 letters. A, B, C. It's not A, B, C. And guys, this is first year stuff. How do we label an angle? The letter we're talking about must be the one in the middle. We're talking about C. So you can say ACB or BCA. As long as C is in the middle. So we think this is 90 degrees. Anyone know how we're going to try to show that that's 90 degrees? And I think we've already covered it already. So we've done already. Slope. Good girl. Julianne, how am I going to show that that's 90 degrees using slope? Get the slope from A to C and C to B. Off you go. Get the slope between C to A and C to B. Do we have our 2 slope formulas? What's one slope formula? X2 minus X1. What's another slope formula? Another slope formula for getting slope, not that one. That we've used for the last 2 weeks in a row? No, not in our slope. Not in our model. Not in our logarithm. We're not doing our homework, guys. That's the problem. Guys, over on our follow. We got to know our 2 formulas. It doesn't make a difference which one you use. Just use one of them. Use y2 minus y1 over x2 minus x1. So use the rise or fall over run. Off you go. Label minus x1 by 1. Okay.
This one A to C, is it? A runs 2 and rises 4 over 2 now. C, B, it runs from 4, 10 to 6, and it falls from minus 3 to 6. Which doesn't make a check that. This is A to C. A is 2, 1, C is go 4, 5, and you go for the 4. So which is it? No, it's not 4, 5.
Right, so let's have a little look at it. A is the point 2, 1. B is the point 10, 2. And C is the point 4, 5. So, show that ABC is a right angle without measuring. We're going to look at the slope. So, one way you could have done it is A to B, you could have used the rise over run. So, A runs from here to here. So, it runs 2 and rises from 1 up to 5, which is 4 over 2, which is 2. A to C, thank you. And then we checked from C to B, which is from C to B, it runs from 4 to 10, which is 6 on the bottom line, and it falls from 5 down to 2, which is minus 3, which is minus a half. So you could have used the y2 minus y1 over x2 minus x1, or this way you would have got the same answer. How do I know they're perpendicular right angles to each other? Because you flipped it and you changed it. If you flip minus 1 over 2, what you get? 2 over 1 and change the sign, you get plus 2. Is that right? So the way we prove this is we say 2 multiplied by minus a half gives us minus 1, and therefore we can say that's true. That's the technical way to say it. So we know perpendicular slopes, you just flip it and change the sign. The technical way to say it is if you multiply them, you'll always get minus 1. It's the technical way to prove it. You multiply any perpendicular slopes, you'll always get minus 1. That's the rule. Right, next bit. Off we go. The coordinate diagram below shows the lines Q, R, S, and T. Q is parallel to S and R is parallel to T. Complete the table below above to show the equation of each line in the diagram. 3 equations and 1 line are already filled in. Right, how am I going to go about figuring out this triangle? One rest. singular, but man. What do we know about N, Julianne? Slope. What do we know about C, Grace? Right. We're not asked to do that on this. I want you to go here next to each one of these, tell me what the slope of the line is, and tell me where it cuts the x before we start the question. It's going to make it really easy. So tell me what the slope of this, so it's right next to it. The slope of each one is, and tell me where it cuts the x. Before we start. It's going to make life way easy. Where it cuts the y-axis. That's just the starters. So, have you got the slope and where it cuts the y-axis for each one? Right. Dermot, what's the slope of this one? Slope is 1. Good man. What is the slope of this one, Dermot? 1. And what is the slope of this one? 2. Julianne, where does this cut the y-axis? Where does this cut the y-axis? And where does this cut the y-axis? +3. We know nothing about this one at the moment. We'll come to that one at the very last. Right. Now, we have to try and match up the letters to which line is which. Now, if you were to guess, what do you think that value is right there? 3, go lad, Dermot. And what do we reckon this value is down here then? -3. Brilliant. Right, Dermot, you have to tell me then, which one of these is Q and which one of these is R? You reckon this is Q and you reckon the second or the third? You reckon that's R? The third, right. What is the difference between this one here and that one there? One of them has a slope of 2 and one of them has a slope of 1, isn't it? Now, what did I tell you last week about the slope? What does a greater the slope mean? The steeper the line. So are we still happy with Q and R the way they are? Which one has a steeper line here? The first one or the third one? Q is steeper, isn't it? It's going up by? It's rising more quickly, isn't it? And which one of these is rising more quickly? This one or this one? The first one or the third one? The third one. This is Q and this is R. They go through the same point. They both go through 3. But this one is rising quicker because there's a slope of 2 and this one has a slope of 1. Right. We didn't have to make up our mind which one of these is S and which, we know this is S, but we don't know what it is. We know this is, then this has to be T. Right. Anyone know what the formula for S is going to be? Brilliant. Y is equal to 2x minus 3. Because it goes through minus 3, but the difference is it's rising steeper, isn't it? 2x. And we know it's parallel to, we know S is parallel to Q, so they have the same slope if they're parallel. Is that okay? Good stuff. Right. Grace, Using algebra, find the point of intersection of these two lines. What am I going to do? Brilliant. Off you go. Simultaneous equation. 20 minutes left, guys. What do we do first? Look like each other. So the x's and y's should always be on the left, and the numbers should always be left over on the right.
You know, if you bring over the x, does it change the sign?
Minus x and bring it over. When you remove the 2x, it becomes minus 2x. Which is what you solve first. No, as long as you get the x and y, it doesn't give. Right. Let's have a little look at it. So, we're going to put these one over the other. So it's minus x plus y is equal to minus 3. Minus 2x plus y is equal to 3. Right, we're going to multiply our bottom line by minus 1, so that becomes plus 2x. That becomes minus y, and this becomes minus 3. They cancel. What's minus x plus 2x? X minus 3 and minus 3? Minus 6. What to do with my x value? I sub it back into my. So minus x plus y is equal to minus 3. Minus x is minus, what's x? Plus y equals minus 3. 6 plus y is equal to minus 3. Y is equal to minus 3 minus 6. Y is equal to minus 9. Like that. And we can clearly see they come up a lot, don't they? So we need to get our head around them. Right. I'll leave the second bit. Right, next bit, let's go. 15 minutes left. We're out the gap and you're free for the weekend. Except for the homework you're going to do this week because the mocks are 3 weeks away. Alright? We're all going to be doing our homework for the next 3 weeks especially. 2 weeks away, mocks are. So, first things first, write down the coordinates of A, B, and C. and then get the equation of each of the lines AB, AC, and BC. Off you go. Right. We're doing B as well. Before we jump into B, I want to make sure we have everything in. Dermot, what's the point A? Julianne, B. And C, Grace? Minus 1. Brilliant, right. First 3 bits are perfect. Right, part B, before we tear into it. Important things I should say we might forget. We're asked to find the equation of the line A and B, AC, and then we're asked to get the equation of the line BC, or CB. Now, first things first, what's my formula for the equation of the line? So, y minus y1 equals m times x minus x1. Now, we're only going to use the formula, the equation of the line for one of these. The reason we're going to use it for one is we know the equation of 2 of these lines without doing it. Very important. You want to make a little note. Write it up here. Make a little note of this, because sometimes people forget this. Is if it's a straight line, horizontally, it's x is equal to something. If it's a straight line vertically, it's y is equal to something. So, if it's a straight line horizontally, it's x is equal to something. If it's a straight line vertically, it's y is equal to something. So, first things first. Aaron, do you know the difference between horizontal and vertical? Which you spend more time doing, between horizontal or between vertical? So you spend more time with horizontal than vertical. No, right, you're dead right. Vertical is the one standing up, and horizontal is the one going across. So, when it's a straight line up and down, like this, sorry, that should be the other way around. Apologies, guys. That should be the other way around. My own fault. When it's horizontally going across like this, it should be y. And when it's vertically going across like this, going up and down, it should be x. Right. So what I mean by that is, this line here, A to C, runs straight up and down through minus 1. So the line AC is very, very simply, AC is x is equal to minus 1. That's the equation of that line. All right, Grace, we're tuned in, aren't we, for the last 10 minutes? Yep. If it runs horizontally, so for example, A to B, it's y is equal to 3 because it runs through 3. Right, Grace, because I know you're paying attention. What is the equation of that line there?
I was paying attention.
Were you? I'd say so. Julianne, come on, tune in for the last 10 minutes. What's the equation of that line there? Not just 3, you got to give me a letter. Dermot? Good man. Come on, guys. I just said it. The equation of this line is x is equal to 3. Straight line that runs up and down through 3. What is the equation, Julianne, of that line there? Y equals 1. Exactly. Y is equal to 1 because it's a straight line that runs over and back through 1. So this would be y is equal to 1. Alright? Now, the only one we do have to use the equation of the line is the last one. They ask us to get the equation of the line BC. And what's my formula, Grace, for the equation of the line? Right, so to get the equation of the line, y minus y1 equals m times x minus x1. Julianne, what do I need? What 2 things do I need to get the equation of the line? A point, and what's the second thing? A slope. So, you need the slope from C to B, and you need either the point B or the point C. It doesn't make a difference. Either one will give you the right answer. Off you go, get me the equation of the line. Off you go, get me the equation of the line between C and B. So get the slope and use either the point C or the point B. Either point C or B. Doesn't make a difference which one you use. So you need the slope from B to C, and you need to use either the point C or point B to get the equation of the line. First thing you need to do anyway is get the slope between C and B. So once we have the slope, we use the y minus y1 equals m times x minus x1 formula. It doesn't make a difference whether we pick the point B or the point C. No. So your point B is 5, 3. So if it's 5, 3, then 5 would be your x1, and 3 would be your y. So 5 minutes left, guys. Really, Sorry? Yep. Right, let's have a little look at it. A is the point minus 1, 3. B is the point 5, 3. And C is the point minus 1 and 8. So we use our formula then. We're going to use the point 5, 3. We've got to get the slope first of all. So we're going from minus 1 over to 6. So our run is 6. And what's our fall? We fall from 8 down to minus 5, so our fall is minus 5. So our slope is minus 5 over 6. Be happy with that? So that's y. Minus y1 is minus 3 is minus 5 over 6 times x minus 5. Is that okay? Multiply across them by 6, 6, 6. They cancel. 6y minus 18 equals minus 5x plus 25 is equal to minus 5x minus 6y plus 25 plus 18 is equal to minus 5x minus 6y plus 43. That okay, guys? Right, use trigonometry to find the measure of the angle between A, B, C, give your answer in degrees, correct the 2 decimal places. We'll come back to that another time. Just to finish off with, off you go, A and B. Here, question 5, A and B. A and B. No help. A and B, and you have 4 minutes to get it done. Feel like is it on the line? We did it last week, we did it the week before, we did it both weeks. Part A and part B we've done 3 times today, anyways, we have no problem with part B. Great. What did you do for part A to check was it on the line? You did. She subbed in 3 and minus 5 into x and y to check was it on the line. So she said, this was our x and this is our y. 5 times 3 plus 3 times minus 5 plus 6 equal to 0. We got 15 minus 15 plus 6 equal to 0. We were left with 6 equal to 0 and it's not. So what can we say? Not on the line. That's how you check it. You sub in the values. And if it's equal to what's left, it is on the line. But we were left with 6 and we should have been left with 0. Good girl, Grace. Well done. Now, what are we doing on the bottom? Simultaneous equation. 1 minute. That's all you have. Like lightning. Right, we'll leave it there, and that's where we'll pick it up the next day. Is that right?